If you're a Java developer, you have many integrated development environments, or IDEs, to choose from. But today, in 2020, IntelliJ IDEA stands out as one of the most powerful tools you can use to build your software. IntelliJ IDEA was originally created for Java programming, and you can use it to build all sorts of Java-based software, from simple console applications to desktop apps to enterprise-strength web applications and everything in between. And in addition to Java, you can use IntelliJ IDEA to work with other JVM languages like Scala, Groovy, and Kotlin. And best of all, the Community Edition of IntelliJ IDEA is completely free. In this course, I'm going to show you how to get started with this incredible programming tool. One warning, though, IntelliJ IDEA is a huge product with hundreds of features. Mastering this IDE takes time, experience, and experimentation. But the good news is that it's easy to get started. My primary focus will be on using the product with Java, but I'll also show you how to get started working with some of those. This course was designed for software developers who want to use IntelliJ IDEA Community Edition to build their software products. IntelliJ IDEA was originally created for use with the Java programming language, but as I'll show you in this course, it supports a lot of other languages and platforms. Regardless of which language you'll be programming with, it's a good idea to get started with Java support, because that's the product's origins, and I think you'll find that regardless of which language you'll be using, navigating the product and using all of its different tools is pretty much the same from language to language. If you want to get started with the language first, though, I do recommend starting with Java. And the very beginning course would be Learning Java. You'll also see that there are a variety of essential training courses in the library for various versions of Java. But once again, when you're first getting started, just the beginning course will be plenty, and then you'll be ready to get the most out of this course about IntelliJ IDEA Community Edition. There are two editions of IntelliJ IDEA, the free Community Edition that I'll be covering in this course, and the Ultimate Edition, which requires a paid subscription. You can download either version from this web page. This page also has a comparison chart that shows the features of each edition. The Community Edition has support for simple Java applications that work from the command line. You can also use plugins to program with other languages, such as Kotlin, Groovy, Scala, and Python. The Community Edition also includes support for the Android plugin, letting you create apps for mobile devices running the Android operating system. When you create a new Android project in IntelliJ, it looks and behaves just like Google's free Android Studio. And that's because Android Studio is really just IntelliJ IDEA Community Edition, with the Android plugin set as the default interface. The Ultimate Edition adds support for many languages such as HTML, JavaScript, CoffeeScript, ActionScript, Ruby, PHP, and Go. But this edition's real focus is on support for server-side frameworks, including Apache Jakarta, formerly known as Java EE, plus Spring, Grails, and Node.js, plus client-side web frameworks such as React.js, Angular, and Vue.js. The Ultimate Edition is just that. With this version of the IDE, you can program just about anything. At the time this course was recorded, there was an option of purchasing just the Ultimate Edition or buying the All Products Pack, a comprehensive license for all of JetBrains' IDE products. Note that there are different prices for individual use or for organizations, and while these are the prices right now, there's no guarantee that they'll stay the same. Either way, the licenses are available by subscription, so moving up to Ultimate can incur an annual cost. But if you prefer to stay with the version that you initially purchase, that's fine too, because with your subscription, you'll get what JetBrains calls a perpetual fallback license. But again, the Community Edition is completely free. If you're new to IntelliJ IDEA, it's a great way to get started and learn the basics of navigating the JetBrains platform. And for many sorts of programming jobs, it'll be all you need. There are a couple of different ways to install IntelliJ IDEA. One approach is to install an application called the JetBrains Toolbox. It's available for Mac, Windows, and Linux, and you'll install it differently for each platform. On Windows, it's a simple executable installer, and on Mac, it's a DMG file, and you'll just drag the application into your Applications folder and start it up. On Windows, from that point on, you'll see the JetBrains icon appear in the system tray, while on Mac you'll see it up here on the menu bar. From here, you can open up the Toolbox application and you can find all of your JetBrains software. If you already have JetBrains software installed, when you install the Toolbox, it'll be detected and it'll show up here. So for example, I had already installed IntelliJ IDEA Community Edition by downloading and extracting it. But now in Toolbox, I see it appear, and I can click here, and that opens up the IDE. You can also go into Toolbox and find other software. So for example, if I wanted to install IntelliJ IDEA Ultimate, I could install it from here, or I could install any of the other IDEs that are available from JetBrains, including RubyMine for Ruby programming, PyCharm for Python, GoLand for Go, and so on and so forth. If you install your IDE software from within Toolbox, its location will be controlled by the Toolbox application, and all of your updates will also be controlled by Toolbox. If you download the software from the JetBrains download page, though, and extract it to your Applications folder on Mac, or install it with the Windows installer, it'll be located in a more conventional location, such as the Applications folder on Mac or Program Files on Windows. It's really up to you, and either way, you'll get the complete software. There will be some minor differences in how you manage the updates, but everything else I show you in this course will act the same, regardless of whether you download the software manually or install it through Toolbox. After starting JetBrains Toolbox for the first time, it'll keep on running in the background unless you explicitly shut it down. And again, on Windows, it appears as an icon in the system tray, while on macOS it shows up on the system toolbar. As I previously described, you can install IntelliJ IDEA either using the JetBrains Toolbox application or by downloading the software from this web page. I've chosen the Community Edition executable, and I've downloaded it to my desktop. I'll double-click to start it up, and after a brief verification step, I'll see the Windows User Account Control dialog. I'll click Yes, and now I'll be running the installer. On this screen, you're asked where you want to install the software, and I'll accept the default under the Program Files directory. On the next screen, there are a number of options available. You can create a desktop shortcut, choose either 32 or 64 bits depending on which edition of Windows you have. You can add a context menu item that will appear when you right-click on a directory in the Explorer application. You can create associations with various kinds of programming files for Java, Groovy, and Kotlin, and you can update your path environment variable so that you can more easily launch the application from the command line. I'm not going to choose any of these options. I'll just click Next, and then I'll click the Install button. It'll take a couple of minutes to extract and install all of the files, but once the installation is complete, you'll be ready to run IntelliJ IDEA for the first time. When the installation is complete, you can check this option and run IntelliJ IDEA. If this is the first time you've installed the software on your computer, you'll see this dialog appear, and if you have previous versions of IntelliJ IDEA installed, you might see them listed with an option to copy the settings over. This is a fresh installation on my computer, so I'll accept the default and click OK. On this screen, I'm asked which UI theme I want to use, and I'll choose the Light theme. And then on the next couple of screens, I'll see various plugins that are available. For the purposes of this course, I don't need any of these plugins, so I'll skip these two screens, and then I'll get to the IntelliJ IDEA welcome screen. If you see this option available saying that plugin updates are available, click it, and the software that I downloaded has an older version of the Kotlin plugin. I'll click Update to download and install the latest version of the Kotlin plugin, and once that part of the installation is complete, I'll be prompted to restart IntelliJ IDEA. Whenever you update a plugin, you should always immediately restart the software, and that'll make sure that you're always using the latest, greatest versions of both the main software and any plugins that you depend on. As I previously described, you can install IntelliJ IDEA either from the JetBrains Toolbox application or by downloading the software from this web page. On this page, you'll find downloads for Windows, macOS, or Linux, and you simply need to select your operating system and download the file. On macOS, you'll get a DMG file. Now, I've downloaded this to my desktop, and I'll open it up, and I'll find that the DMG file has an application package folder. From here, you simply click and drag into the applications folder, and you've installed the application. Now, I had already done that, so I'll go to my applications directory. I'll find the application, and I'll start it up for the first time. You may see a security prompt asking you whether it's okay to start up this software that you downloaded from the internet. And then if this is the first time you've run IntelliJ IDEA on your computer, you'll see this dialog appear asking you for settings. If you have previous versions of IntelliJ IDEA installed, you might see them listed here, and you might be offered the option of copying those settings. I don't have previous versions installed, so I'll accept the default and click OK. And that takes me to this screen that lets me customize the IntelliJ IDEA user interface. I prefer the light interface, so I'll choose that. Then I'll click Next. And if I like, I can create a script for opening files and projects from the command line. I'll select that option, and then go to the next screen to choose Featured Plugins. From here, you can choose plugins for various programming tasks. For example, if you want to build Android apps, you could choose that plugin. And there are other plugins available on this screen as well. There are other plugins, too, that you won't see in these options because they're already installed automatically. But after you've made your selections on this screen, you can start using IntelliJ IDEA right away. If you chose to create a launcher script, you'll be prompted for an administrative password. Enter the password and click OK, and then you'll be at the IntelliJ IDEA welcome screen. From here, you might see an indication that plugin updates are available, and if you see that, click the link. And for example, right now, there's a newer version of the Kotlin plugin than the version that was packaged in this installation. I'll click Update and wait for a moment while the new version of the plugin is downloaded and installed. And whenever you install a new plugin, you'll be prompted to restart IntelliJ IDEA. You'll always want to do that to make sure you're using the latest, greatest version of both the main software and the plugin. I'll click the Restart IDE button and then confirm. And after a moment, IntelliJ IDEA comes back, and I'm ready to program. After installing IntelliJ IDEA, the next step is to install a copy of the Java Development Kit. The JDK is available from many locations. You could choose to download and install the software manually, and it'll be placed in whatever the default directory is for your operating system. On Mac, that's a directory called library/Java that's under the root directory. From there, there's a Java Virtual Machines directory, and notice I already have Java 15 installed. On Windows, you would look under the Program Files directory, and from there under Java, and you'll find basically the same thing. Now, you can choose to use one of those existing copies of the JDK, or, as I'll show you, you can download the JDK from directly within the software. From the Welcome screen, I'll go to Configure, Structure for New Projects. Under Platform Settings, I've chosen SDKs, and now I'll click Plus. Notice that copy of the JDK in the computer-wide directory was detected, and this should happen regardless of which operating system you're on. You can choose that, or you can download a copy of the JDK by choosing Download JDK, and then choosing a vendor. And you'll see that there are a number of vendors that offer free copies of Java. I'll choose the default Oracle OpenJDK. With this vendor, you only get one version, whatever is the most recent release, and I'll click Download. Notice up here, you'll see a different location when you download the software this way. Instead of being under a library directory under the root directory, now you're under your home directory. And so that's the difference between the two approaches. In this JDK definition, I'm using a copy of the JDK that's in the root directory, and in this one, I'm working with a version in the home directory. You can have as many versions of Java installed as you want. So if you have one project that's still using Java 8, you can have that installed, and another one that's always going to use whatever the most recent version of Java is, that's fine too. Each copy of the JDK will show the home path, and you can also see where the source code is, any annotations, and as I'll show in a later video, you can also set up documentation paths that make it easy to get to the help you need as you're programming and need to understand how various classes and packages work from the Java Development Kit. Once you're finished setting up the JDK, click OK to go back to the welcome screen, and now you'll be ready to create your first Java project. After installing and configuring IntelliJ IDEA and installing a copy of the JDK, you're ready to create a project. From the welcome screen, I'll select New Project. On the left, you can decide what kind of project you're creating. You can choose a primary programming language, such as Java, Groovy, or Kotlin. You can also choose one of the available frameworks for managing dependencies. Dependencies are links to external libraries. Maven and Gradle are two frameworks for working with libraries that are managed in repositories. For this first project, I'm going to create the ultimately simple application, a Hello World application written in Java. You can also choose which SDK you want to use, and in the previous video I showed you that you can use versions of the JDK either from the root directory or from the home directory. I'm going to stick with the OpenJDK version that I just downloaded and click Next. For Java projects, you can choose to create a project from a template called the Command Line app, and I'll choose that. Then I'll click Next, and I'll call this project Hello World. Now you can name the project anything you want, but the location directory shouldn't ever have spaces in it. So I'll get rid of the spaces, and you can also set the base package. In Java, that means you're saying where you want your code files to go, and also how you're going to access them from other code in your project. I'm going to call my base package com.example, and then I'll click Finish. And I'm told that the project directory IDEA projects doesn't exist, so it has to be created. So I'll click the Create button, and that creates the project and the folder where it's stored. The first time you open the entire user interface, you'll see the Tip of the Day dialog. You can click Next Tip and Next again to see all kinds of good information, but if you don't want that to happen in the future, check this option and close the window. The first thing I notice is that the text is pretty small. On Mac, I'll go to IntelliJ IDEA and choose Preferences, and on Windows, I would go to the File menu and choose Settings. Then from there, I'll click on Editor. I'll click on Font, and I'll change the size of my font from 13 to 14, make it a little bit bigger. Then I'll run the application by clicking this Run Main button up here, and down here you'll see a couple of notifications indicating that the project is being built, and then you'll see a bit of output indicating that something happened. Now, this code isn't doing anything yet, so I'll go back to my code up here, and I'm going to add a new line and type SOUT. This is a shortcut, or something called a template, that expands when you press the Tab key to complete code. It expands to system.out.println, which is how you print a line of code in the console. Then I'll add a string that's wrapped in double quotes, and then I'll run the code again, and down at the bottom, after a moment, I see the output of my simple application saying, Hello World. So if you've gotten this far, you've correctly configured IntelliJ IDEA with a copy of the JDK, you've written some valid Java code, and you've executed it. And now you'll be able to add whatever components you need to build your software. IntelliJ IDEA receives frequent updates from JetBrains. Some of these updates are minor changes for bug fixes, while others are major releases. You can check the version number to see whether you're working with a major or a minor release. The version numbers start with the year of the release and then a major release number. I'm working with 2020.2, and then if there's a point release after that, that's a minor update. You can update IntelliJ IDEA in a couple of different ways. If you installed IntelliJ IDEA from the JetBrains website, not using the Toolbox application, from the welcome screen you can go to the Configure menu and then choose Check for Updates at the bottom. Depending on the configuration of your copy of IntelliJ IDEA, you may see an offer to update to a preview release. You can control this by clicking on the Configure Updates link. Notice that I'm looking for something called the Early Access Program. If I'm using IntelliJ IDEA to do production work, I may not want to deal with preview software, in which case I can change to a channel called Stable Releases. Click OK. After you change the update configuration, close this dialog, then run Check for Updates again, And now I see the message that I have the latest version installed. There are 3 channels available: stable releases, use that for production; beta releases or public previews; or for the very adventurous, the early access program. This update process manages the main software. As I described previously, plugins are handled separately. Now, if you installed IntelliJ IDEA using the Toolbox application, updates work differently there. Using Toolbox, I have a copy of IntelliJ IDEA Ultimate, just so I have 2 versions of the software. And if I open the software from there, I'll get to the welcome screen. And then once again, I'll try to check for updates. And this time I see a message saying that the updates are managed by the Toolbox app. If you're managing IntelliJ IDEA through the Toolbox application, all of your updates will be handled here. You can click on this little gear icon and check Settings. From there you can choose Updates, and then once again there's an option to update to Early Access Program releases. My recommendation is to only use the EAP releases if you're experimenting or curious. If you're doing production work, you should stick with the production versions of the software. Finally, I'll go back to my Community Edition software, and I'll open my project Hello World. And I'll show you that you can also check for updates from within this UI. Go to your Preferences or Settings. On macOS, that's IntelliJ IDEA, then Preferences, and on Windows, it's File and then Settings. Then from there, go to Appearance and Behavior, to System Settings, to Updates. And you'll see basically the same user interface that lets you choose a release channel and check for available updates. IntelliJ IDEA is highly configurable, with hundreds of different options that affect its appearance and behavior. I've already shown some of the options. For example, when you first install IntelliJ IDEA and start it for the first time, you can control the theme, whether it appears with a dark or light appearance. And I showed how to set a font. But here's where you can get to a lot more settings. From the welcome screen, click Configure, and then on Mac, choose Preferences, or on Windows and Linux, choose Settings. And that'll take you to this dialog. If you already have a project open, you can do the same thing. On macOS, you would go to the IntelliJ IDEA menu and choose Preferences, while on Windows and Linux, you would choose File and then Settings. The Appearance and Behavior category includes settings for appearance, menus and toolbars, a bunch of items under System Settings, file colors, scopes, and so on. The key map lets you control keyboard shortcuts. All of your keyboard shortcuts are visible through the menu. So, for example, if you want to find out what the keyboard shortcut is, say for looking at a tool window, you can go to the menu and choose View, Tools, and then look at the keyboard shortcuts listed there. I'll go back to Preferences here, and once again go to Key Map, and then from there I'll look at Tool Windows, and there are all the settings. If you want to change one of these settings, double-click, and then you can add keyboard or mouse shortcuts, abbreviations, or you can remove existing shortcuts. Under the Editor category, there are general settings. This is how you control certain appearance things, such as soft wrapping text, or changing the font size with your Command or Control and the mouse wheel. There's a section called Code Editing that lets you highlight various parts of your code as you move the cursor around. The font setting, which I showed previously, 2 settings for colors, including the style and the scheme, and many more settings that affect the editor's behavior. Under Plugins, you'll see both the plugins that are currently downloaded and installed, plus all the others that are available for download. The Installed tab right here shows you what you already have. So, for example, by default, you already have Kotlin support and support for Gradle and Maven. But if you want to go get other plugins, you can click on the Marketplace tab and then search and find what you're looking for. So, for example, if you wanted to work with Amazon Web Services, you might try the AWS Toolkit. Under Version Control, there are settings for managing various kinds of version control systems, including Git and GitHub, which currently are the most popular, but also older systems such as Mercurial and Subversion. The Build Execution Deployment section has settings for controlling your build tools, the compiler. There's a whole section for Android, which Android app developers might know how to use. And then under Languages and Frameworks, you'll find settings for specific languages. So for example, if you wanted to build a desktop application with this older legacy library, JavaFX, there's a setting for that. If you want to use the Markdown language for documentation, there's a setting for that. And there's a whole section for Kotlin. For example, if you want to update the Kotlin plugin, this is where you would go. Select Kotlin, check for a more recent version, and if there is something available, you'd be able to install it here. Finally, the Tools category has sections for web browsers and other external tools for testing code, server certificates if you're going to be doing server-side coding, and a tasks window. There are so many different settings or preferences in IntelliJ IDEA that no single developer will ever use them all. I encourage you to explore the Settings or Preferences dialog and see what's available to control the behavior and appearance of your installation of IntelliJ IDEA. The structure of a Java project in IntelliJ IDEA depends on the options that you selected when you created the project. The simplest projects, like the one I'm looking at now, have a single file, and that file's directory location will depend on the package. In Java, for example, the package also translates to a directory structure. So in your source code root directory, you'll have a com subdirectory, an example subdirectory of that, and then the file main.java would be in that directory. You can see that directory structure in the project window, which you can open by clicking on the tab in the top left, or by going to the menu and selecting View, Tool Windows, Project, or by pressing the associated keyboard shortcut. The project window points at the project root directory. On Mac, the tilde character means the home directory, and if you're working on Windows, you'll see something similar. The IDEA Projects directory is just the default directory name where new projects are created, but there is nothing magical about that directory name. You could create your project somewhere else if you like. Under the project directory, you'll see 3 subdirectories minimally. The src or source directory will contain your code. By default, package directories that are empty will be compressed. So while there's actually a com directory with an example subdirectory, the project window is showing that as a single entry. If you want to see that in a tree, click on the gear icon and then unselect Compact Middle Packages, and you'll see the true subdirectory structure displayed. The out directory is where your compiled classes are placed. Under out, there will be a production subdirectory and then another subdirectory under that with the name of the project. From there, once again, you'll see the package structure. In this case, a com directory with an example subdirectory and then the compiled class. If I go back to that configuration and turn Compact Middle Packages back on, you'll see that it's compressed in the source directory but not in the out directory. The .idea directory contains a bunch of configuration files. Many of them will be regenerated automatically if you were to delete them, but some of them contain important information that you shouldn't change unless you know exactly what you're doing. So for example, the modules.xml file controls the modules. A single project can have one or more modules. By default, a simple Java application will just have one module like this one. Workspace.xml has all kinds of settings that manage the appearance and behavior of the editor and other elements of the user interface when you're in this project. And .gitignore is an important file when you're working with source control using Git, say on GitHub. You can add names of files here to indicate that you don't want to check in those files and you don't want to track them in the source control system. Down here, there's a virtual subdirectory called External Libraries. Most of the time you can ignore this. This shows all the different core libraries in the standard JDK runtime. So for example, there's java.rmi, java.scripting, java.sql, and so on. You'll never change these settings, but this tool gives you troubleshooting capability, say if you're not able to find a particular class that you think should be there. And finally, there's an IML file. It'll have the same name as the project, and this is a critical file that manages all the other files. The modules, the workspace setting, the folder where you're creating your source code files, and so on. Now, as you add more capabilities to your project, say if you're using dependencies and you're using the Maven or Gradle frameworks, you'll see more directories and more configuration files. This is just the simplest structure that you're going to see when you create a brand new Java project in IntelliJ IDEA. IntelliJ IDEA has a feature named LightEdit that lets you edit just one file without creating or loading an entire project. When you use IDEA this way, it behaves as a simple text editor. It does a little better than a basic text editor. For example, you get a certain amount of navigation and color coding, but you don't get code completion and you can't run the application. I'll demonstrate this feature with a copy of a main.java file that I've extracted from a project and placed on my desktop. I'll right-click on it and choose Open With, and then I'll choose IntelliJ IDEA. It takes a moment to load, but then when you see the file, you'll see the color coding you might already recognize. So for example, package, public, and class are keywords, so they get one color. Literal text gets another color. Comments are grayed out, and so on. So IntelliJ IDEA is recognizing the programming language and helping it be more readable. You'll even get functionality such as the ability to expand these templates into full code. Sout expands to system.out.println. You get code collapsing, and of course you can search for code and you can make any changes you like. But up here you'll notice that the Run button is grayed out, and if you go to the Run menu and try to choose Run, nothing happens. You could go into Edit Configurations and jump through a bunch of hoops and see if you can get the file to run, but honestly, that's not what this feature is for. LightEdit is for looking at and making really minor changes to files where you know exactly what you need to do. There is an option for setting up an SDK, and you'll get a little bit more functionality that way, but once again, you can't run the file. So if I go over here and I right-click on main.java, in a project, I would see a menu option to run that file. In LightEdit mode, you don't get that capability. So LightEdit lets you use IntelliJ IDEA as a simple text editor that's at least programming language aware. But when it comes time to build your application and compile it to .class files, you'll want to take this file and wrap it in an actual IntelliJ IDEA project. IntelliJ IDEA has tools for online help that you can use to learn more about the IDE, but it also gives you context-sensitive help for the languages and frameworks that you use most frequently. Specifically for Java API docs, you have to configure this yourself. Now for these demonstrations, if you're working on a Mac, first make sure that your keyboard shortcuts, known as the key map, are set to macOS. Go to the IntelliJ IDEA menu and choose Preferences, then choose Key Map, and check your key map selection here. If you're working on Windows, it should be set correctly already. Now, place the cursor inside the keyword system, that's the name of a Java class, and press the F1 key. And on Mac, you'll see a pop-up window that shows you some simple documentation about that class. But there's a lot to know about that class, and it would be nice to be able to get to the external API docs, that is the complete documentation for that class. There's a keyboard shortcut that's supposed to do this, Shift F1, and it's supposed to work on all operating systems, but by default it won't do anything. To fix this, go to your Project Structure dialog. Go to the menu, choose File, then Project Structure, and then under the Project SDK, click Edit. Click the Documentation Paths tab. Down at the bottom, if you click on the plus icon, you'll see a default location, but there's a giveaway here that this isn't correct. If you see the term Early Access, and then you actually try to use this URL, it won't work, because that's an old URL. Instead, go find the actual URL for the API docs for the version of Java that you're using. I'll go to my browser and I'll search for Java 15 API docs. I'll click into this link, and now I'm at the root directory for the API docs for Java 15. I'm going to copy just this directory structure and leave off index.html. I'll copy that to the clipboard. Then back in IntelliJ IDEA, I'll click that plus button with the planet again, and I'll paste that URL into place. I'll click OK, and then click OK again. Now back in my code, I'll once again place the cursor in the keyword system, that's the name of the class, and press Shift F1, and I go directly to the documentation for that class. The same thing can work with method names, but a lot of times you'll get a lot of options. So for example, the complete documentation for println is in the print stream class documentation. I'll choose one of these, and I jump right to the documentation for that method. Now, I got here through the project structure dialog for this project, but that definition is actually for the SDK no matter where it's used. So if I create another project that uses the same SDK, the online help will already be configured. Those are the available online help tools for context-sensitive help as you code. And again, there are tools for getting to the documentation for the product itself, for IntelliJ IDEA, or for the programming language. And again, you can get to documentation for the product itself or for the programming language. IntelliJ IDEA's user interface is organized with windows. Each window has a specific purpose. Most of them can be shown or hidden, depending on what you're doing at the moment. But at the center of everything, both literally and figuratively, is the editor window. That's where you work with your source code, editing, searching, refactoring, and so on. You can search the code in the current editor window using the Find tools. These are available from the menu under Edit, Find. There's a Find and a Replace, and many other different actions. Let's say, for example, that I wanted to find the word hello. I'll select Find and type hello, and I see that string highlighted. If I want to find a string that occurs more than once, I can type it in, and I'll see the word public is there a couple of times. Now I'll search for the word main with an uppercase M, and I see both instances of the word selected, but I'll click this icon to match the case, and now I only select the string that matches the version that I typed in. There's also an icon to find full words, and another one for regular expressions. You can also do a search and replace. This time I'll use a keyboard shortcut. On Mac it's Command-R, and on Windows Control-R. And I'll look for the word hello and replace it with the word hi. And then I have options to go through different occurrences or just to replace all. When I press Escape, the Find tools go away. You can create multiple editor windows that display the same file. Right-click on the tab for that editor window and choose one of the split actions, either vertically or horizontally. I'll split this one vertically, and then I'll split this one horizontally. And now I have 3 windows showing the same file. Only one of those windows can be active at a time, and you'll know which one by the blinking cursor. If I click up here, I see the cursor up there. Now, if I start making changes in one window, I'll see them reflected in the others, because there's still only one file there. And to get rid of the extra windows, just click on the X on the tab, and you're back to a single window. You can expand the editor window to take up all available space by double-clicking on the tab. And there are other options available to take up even more space. These are under the View menu, under Appearance. So, for example, I could choose Enter Full Screen, and that gets rid of the menu at the top. I'll exit that mode by going to Appearance and then Exit Full Screen. And then I'll try a few of the others. This is called Presentation Mode, where you see the text in very large font. I'll exit that mode, and this time I'll go into Appearance and choose Zen Mode. And this gets rid of all the Chrome or toolbars and menus all around that maintains the same font. And then I'll come back to Appearance and exit that as well. And now I'm back to the standard view. Finally, you'll notice that you don't need to explicitly save your changes. IntelliJ IDEA works like cloud-based editing systems, such as Google Docs or Microsoft Word when you're working with OneDrive. As you type, IntelliJ IDEA is saving your changes automatically. This isn't done constantly. There can be a difference between the document in memory and the one on disk. But whenever you close a file, those changes will be saved. And if you want to make sure you're saving as you code, you can always go to the menu and choose File and Save All. And again, there's a keyboard shortcut associated with that action. IntelliJ IDEA's project window lets you find all of your files and see your file and folder structure for your project. You can get to the project window by clicking on the tab on the top left, or you can go to the menu and select View, Tool Windows, Project, and you'll see that there's a keyboard shortcut associated with that. Or, as with many of the tool windows, you can move the cursor down to the lower left, hover the cursor over that icon down there, and you'll see a pop-up menu that offers some of the most commonly used windows. The project window has multiple scopes. The scope determines how the files and folders are displayed. The default scope is also called project, and it shows the actual directory structure of your project, and also a lot of the files and folders that might be hidden depending on your operating system if you were looking at that project directory in a file manager application. Here are some of the scopes that are available for Java-based projects, and the scopes will change depending on what language you're working with. The packages scope will narrow down to just showing classes that are parts of various packages. Just as with the product scope, you can expand those packages. I'll select that project line and then click on the gear icon and deselect compact middle packages. And now I'll see all of my package levels. I'll go back to that setting and I'll recompact. The project file scope narrows down your view so you're only seeing files that are a part of your project. So now I'm no longer seeing the libraries that are a part of the core Java runtime. The production scope shows you just the classes that are going to be compiled into your application. The test scope would show you testing files, say for JUnit, and I don't have any of those in this project, so that's empty for me. The problem scope will show you where you have coding problems. So for example, if I click over here and get rid of this semicolon, that's now a coding error, and I see the class show up in the problem scope. I'll close main.java, then come back over here, and double-click, and that reopens the file and places the cursor exactly where the problem is. When I fix the code, the problem goes away. There are also scopes called Open Files and Scratches and Consoles. I'll go to Open Files, and that looks pretty much the same as Production right now. And then I'm going to add a new Java class. I'll right-click on the example package, and I'll select New Java Class, and I'll name the new class, and the new class appears in this scope. Now when I close the class, it disappears. But if I go back to the project scope, I see that it's there, and I can double-click and open it. So the project window has all these different scopes, and each scope defines how you view your files and your folders. I've previously described how to use the project window. IntelliJ IDEA has many other tool windows that you use as you develop your application. These are available from a couple of different places. You can open tool windows by selecting View, Tool Windows, and you'll see the windows that are available for your project. And this list will differ depending on what language you're using and what platform you're developing for. You can also get to these windows with keyboard shortcuts, or you can look at the tabs that are wrapped around the user interface. This opens the Structure window, which shows the structure of the current class. I'll go to the new class file, and I'll see the structure for this class, and I'll see that there's nothing there. Add an override of the toString method. To do that, I started typing toString, and I saw an offer to override the method, and I pressed Enter or Return. And then, instead of returning super.toString, I'll return a literal string of my new class. Over in the Structure window, I now see that value appear. Here are some other windows that are useful. The Problems window will show you issues with your code. Right now, I'm being told new class is never used. And if I double-click there, I'll jump to the definition of the class. To fix that, I'll come back to my main class, and I'll create a new variable that I'll call new class. I'm working in Java 15, so I can use the var keyword. And I'll say I'm creating an instance of my new class. Now my Problems window shows a different error. It tells me the variable new class is never used. So I'll use sout for printing to the console. That expands to system.out.println, and I'll output the value from that method, newClass.toString. And now my Problems window is empty. Now I can run the class. I can do that by clicking on the Run button up here on the toolbar, or I can click on the Run button right next to the main method or next to the class. If I do it this way, I'll see a menu and I'll say Run Main. And that builds and runs the application. And that takes me to another tool window, the Run window. There are also windows for Terminal, which takes you out to a command line, for Build, and that tells you the details of your building process. And over here at the top right, if you're working with Java, you'll see an Ant window. Now, if you're not using Ant to build your applications, you don't need to worry about that window, so you can just close it. So again, you can get to the various tool windows from this menu, or you can get to them through the keyboard shortcuts or the tabs, or as I showed previously, by moving the cursor to the icon in the lower left, and you'll see a list to choose from of your most commonly used tool windows. IntelliJ IDEA's tool windows are placed in default locations. For example, the project window appears in the top left corner, the Run, To Do, Problems, and Build windows appear at the bottom, and the Ant window appears in the top right. But you can move any of those windows around as you like. You can do this by simply dragging and dropping. So for example, the Structure window, which starts off on the left side of the screen, can be moved over to the right side of the screen simply by dragging the tab over. Or you can go to the gear icon for any window and select Move To and move it to a different location. So I'll go here and select Move To and put it in the bottom left. And then I'll move it again, and this time I'll move it over to the top left. You can also change the positions of the tabs around the edges of the user interface. The Project tab by default appears at the top, but I can click and move it down, and then I can click and move it back up again. These tabs will sometimes move around on their own, depending on what actions you've taken most recently. The Favorites tab appears down at the bottom left, and it gives you a way of keeping track of your favorite files. The Hello World file was automatically added, but you can also add other files. So for example, I'll go to the New Class file, I'll go to the Project window, and then I'll locate that file by using this icon called Select Open File. Now I'll right-click on that file and select Add to Favorites, and I'll add it to a new favorites list. And I'll call it My Favorites. Now I'll close that file, then I'll come back to the Favorites window, and I'll double-click to reopen the file. So you have control over the positioning of the windows, and you can use all the different tool windows to find your files and navigate your project. IntelliJ IDEA gives you the ability to assign keyboard shortcuts to any action. You can usually execute actions through the menu. So for example, if you wanted to sort lines of code, you could go to the Edit menu and choose Sort Lines, but notice that there's no keyboard shortcut attached to that action. So to demonstrate this, I'm going to create a simple text file. I'll place this text file in my source directory, not in the packages, because it won't be a Java file. I'll right-click and select New, File, and I'll call this file states.txt. Now I'll type 3 names of American states: Washington, Oregon, and California. Now to sort that text, I'll go to the menu and select Edit, Sort Lines, and that sorts those lines alphabetically, and then I'll choose Edit and Reverse Lines, and now the data is sorted in reverse order. Now I want to attach keyboard shortcuts. Go to your Settings or Preferences dialog. On Mac, I'll go to IntelliJ IDEA and Preferences, and on Windows or Linux, you'd go to File and then Settings. Next, find the action you want to assign the keyboard shortcut to. If you know where it is, you can go through the menu, or you can search for the action here. I'll look for Sort Lines. It's under Editor Actions. I'll double-click that, and then select Add Keyboard Shortcut. I'll click into this text box, and then I'll press Ctrl-Shift-S. If you choose a keyboard shortcut that's already assigned to some other action, you'll be notified. If you don't see anything, it's good. I'll click OK, and now I can use that keyboard shortcut. Now I'll do the same thing and assign a keyboard shortcut to Reverse Lines. There it is, and I'll double-click it, select Add Keyboard Shortcut. I'll click into the text box and press Ctrl-Shift-R, and this time I'm told that this keyboard shortcut is already assigned to another action. I'll click OK, and when prompted, I'll say I want to remove that assignment from that other action. And now it's assigned to the Reverse Lines action. I'll click OK, and now I can use my new keyboard shortcuts. Ctrl-Shift-S to sort in alphabetical order, and Ctrl-Shift-R to do it in reverse. And you can use that keyboard shortcut as many times as you want. Now there's a side effect of having assigned a custom keyboard shortcut. I'll go back to my Preferences dialog, or Settings if you're on another operating system, and notice the color has changed here. And up here, I'm no longer using the macOS key map. I'm using something called macOS Copy. That was created automatically for me. In previous versions of IntelliJ IDEA, I would have had to explicitly create a new key map. Now it's done automatically as soon as I start customizing. If you want to go back to the default, you can always pull down this list and select the original key map for your operating system. So that's how you can customize your own keyboard shortcuts and assign them to any action in IntelliJ IDEA. IntelliJ IDEA makes it easy to create new components in your application. If you're working in Java and you want to organize your code, you might want to create a new package. And you can do that easily by right-clicking on an existing package in the project window, selecting New, and then Package. You'll see this dialog pop up, and you can add a new sub-package under the existing package. For example, I might want a model package, or you can create one that's more deeply nested. I'm just going to create the model package, and then I'll right-click there and create a new class. Now, when you create a class, you're actually saying I want to create a new component, and you can choose in this dialog whether it's going to be a class, an interface, an enum or enumeration, or a custom annotation. I'll create a class called Person, and that creates the new file. You can also create new components from the menu by selecting File, New, and once again you'll see Java class there. If you're working in another language and you've installed the plugin for that language, you'll see entries for that language. So for example, this would let me create a new Kotlin file, class, interface, enumeration, or object. That's how easy it is to create new components for your software. And again, you do that by going to the project window and selecting where you want the component to go, or you can go from the menu and select File, New from there. IntelliJ IDEA lets you generate code. There are tools for generating new properties and new boilerplate code that's common in Java and other languages. Now, to follow along, start with a simple class. I've created a class called Person, and I'm going to add some fields to this class. I'll make them private. I'll start by typing the word private, and then the first one will be a string, and I'll call it first name. Then I'll create another string, and I'll call that last name. And then I'll create an integer field, and I'll name that age. In Java, you'll typically want to create setter and getter methods. And this will be the first example of how you can generate code. I'll place the cursor on that last line, then I'll go to the menu, and I'll choose Code, Generate. And notice that there's a keyboard shortcut associated with this action. Now I'll select Getter and Setter, and I'll see this dialog pop up. I'll hold down the Shift key and then click on the last field, so I'm selecting all of them, and then I'll click OK. And that generates all of the setters and getters I need for all of those fields. You can also use the Generate function to create new constructors. Once again, I'll go to Code and Generate, and this time I'll choose Constructor, and I'll choose all three fields again, and that gives me a constructor that receives all three values and saves those values to the private fields. This time I'll use the keyboard shortcut, and I'll see the dialog pop up, and once again I'll choose Constructor. This time I'll choose None, and I get a No Arguments constructor. And then finally I'll generate one more method. In Java, there's an automatic toString method, but the default method doesn't return anything really useful, say for debugging. So I can go to the menu and choose Code, Generate, and this time I'll choose toString. Once again, I'll choose all three fields and click OK, and that generates a new toString method that overrides the superclasses version. It then concatenates the name of the class and all of the field's values together so that when I'm debugging, I can output those values easily to the console. Notice that the placement of the method will depend on where the cursor was when you called the function. If you want to move this function, you can use one of the keyboard shortcuts for moving code around. On Mac, hold down the Command key, or on Windows, Control, and then Shift, and press the down arrow multiple times until the method is at the bottom of your code. Again, that's Control-Shift up or down on Windows and Command-Shift up or down on Mac. There are other functions available for generating code, and you can explore some of them in the Generate dialog. When you're coding in a hurry, you sometimes don't pay attention to things like indentation or line feeds to make your code readable. IntelliJ IDEA can clean all that up for you with a tool called Reformat Code. Here's a couple ways you can use it. I'll start with this class called Person, and I'm going to select everything, and I did that by pressing Command-A on Mac or Control-A on Windows. Then I'll press Shift and Tab a few times to indent everything over to the left. Now I want to add indentation back in. I'll click anywhere in the code editor, then I'll go to the menu and choose Code, Reformat Code, and everything is fixed instantly. Now there's another way of using that Reformat Code tool. I'm going to press Command-Z for undo on Mac or Control-Z on Windows, and now I'm back in that same state. And now I'll come back over to my project window, and with person.java selected, I'll click on this icon called Select Open File. I'll right-click on the file in the project window, and I'll choose Reformat Code. And now, because I've selected a file in the project window, the behavior is different. This time, I get a dialog that pops up, and it asks me what I want to do. I'll say I just want to clean up the code, and I'll click OK, and the same fix happens. Reformat Code can handle very extreme reformatting. This time, I'm going to replace all of my line feeds. I'll click into the text editor, then I'll press Command-R on Mac or Control-R on Windows to look for the Replace UI. I'll press Enter or Return to say that I'm looking for line feeds, and then I'll get rid of anything here, and I'll click on Replace All. And now I've really kind of crunched all my code together. I'll right-click on the person class again, and I'll choose Reformat Code, and OK, and everything gets cleaned up. Now notice that operation resulted in some errors in the code. So now I'm going to go to my Problems window. I'll double-click on this error, saying there's no such thing as override public, and it looks like I need to add a space character there. And then this time I'll right-click and I'll choose Reformat Code, click OK, and everything is now cleaned up again. When you reformat code, you have an option of optimizing imports. In Java, Kotlin, and other languages, imports indicate what classes from other parts of the application you want to use. To demonstrate this, I'll go to main.java, and I'm going to add a new instance of my person class. I'll start with var person equals new person, and when I select the class, IntelliJ IDEA automatically adds an import statement at the top of the class. Now I'm going to auto-complete this statement by holding down Command on Mac or Control on Windows, and then Shift and Enter or Return. And that finishes the statement. Now I'll create an instance of a print stream class. I'll call it stream, and I'll use new print stream. I'm not actually going to be doing anything with this, so I'll just pass in a pair of double quotes. Once again, I'll complete the statement. Now to add the import, I'll move the cursor onto the class, and I'll press Option Return on Mac or Alt Enter on Windows, and that results in adding the import at the top. So I'll do that again, and this time I'm asked to add an exception to a method signature. And now I have 3 imports at the top of my file. Now let's say somewhere along the way that these imports had been moved around, so that they're not in alphabetical order anymore. To fix that, I can now choose Optimize Imports from the Code menu. I'll select Code, Optimize Imports, and that's all fixed. Or I can put that error back in, and I'm also going to take out all my indentation. And now I'll select this file, right-click on it in the project window, choose Reformat Code, and now in my Reformat dialog, I'll choose Optimize Imports and Clean Up Code, click OK, and everything is fixed at the same time. So IntelliJ IDEA knows how to reformat your code to make it more readable, and it knows how to alphabetize and otherwise organize your imports, and it also knows how to resort and regroup your imports so everything is highly readable. IntelliJ IDEA gives you many ways of searching for your code, either by looking for literal strings, or for names of files, or for symbols such as classes and identifiers. If you don't have any code files open, you'll see some hints right here on the main screen. So for example, one of the easiest ways to find a file is to press the Shift key twice for Search Everywhere. This dialog has tabs across the top that let you filter your search, so you're only looking for classes, files, or symbols. And there's also the Actions tab that lets you look for actions you can execute in IntelliJ IDEA. Let's say that I'm looking for my main class. I'll click the All tab and start typing main, and I see the main class in com.example, but I also see a symbol, a method, named main. I'll double-click on the class, and that opens the file. Now, let's say I wanted to search for the literal string hello world, but I didn't know where it was in the application. I'll close my file, and this time I'll select Edit, Find in Path. I'll type hello world, and I see that string is right here. I'll double-click on it, and that opens the file and places the cursor in the location where the string occurs. Under the Find menu, you'll also find Find and Replace. Those features are only looking for code in the currently focused file. Also, Find Next and Find Previous Occurrence and Select All Occurrences, and other features. And again, notice that each of these actions has an associated keyboard shortcut. You can also start from a file and figure out where it's being used. I'll right-click on the Person class and select Find Usages. And down here, I see that I'm using that class from my main class. I'll double-click, and I open to that instance. You can also do the same thing with the keyboard shortcut. I'll go to the Person class. I'll place the cursor right here on the class declaration, and I'll hold down Option on Mac or Alt on Windows and press F7, and that calls the Find Usages feature. And once again, I'll see all the different references to places in my code where I'm using that class, and I can double-click and go to the use. You can find and replace in other files. You can start from one file or one method and find all the usages of that file or method, and you can figure out where to go for any of IntelliJ IDEA's own actions by using the Search Everywhere dialog, clicking on Actions, and searching for the name of the action. When you need to make changes to your code, you can do simple searches and replaces, but that can be error-prone. It's always better, if possible, to use refactoring. When you refactor, you're letting the IDE make the changes for you. It'll look at definitions of symbols, and it can change both the definition and the references or usages of that symbol throughout an application. One of the simplest refactoring operations is renaming variables. Let's say I have a variable called person, which is an instance of a class called person, and this particular class has two different constructors. To learn about the constructors, I'll place the cursor between the parentheses and press Command-P on Mac or Control-P on Windows, and I'll see that there are two constructors available, a no parameters or no arguments constructor, and one that lets me pass in initial values. I'll pass in 3 values, a first name, a last name, and an age. Then I'm going to output this person object using that class's toString method. I'll start with sout, which means system out. I'll press Enter or Tab, and that expands to system.out.println, and then I'll pass in the person variable. When I run the code, it'll result in outputting the person object and its values. And that's because of the toString method that I generated earlier. Now I'll come back to the main class, and I want to rename this variable. Now again, I could do a search and replace, but I want to make sure that I'm only changing the variable names, not the name of the class itself. So I'll place the cursor in one of the references to the variable. It can either be where I declare it or where I'm using it, it doesn't matter. Then I'll go to the menu and choose Refactor, Rename. And notice that there's a keyboard shortcut associated with this. Then I'll change this from person to my person. And as I type, I'm changing that variable name everywhere it occurs. When I press Enter or Return, that will accept the changes. You can also use refactoring to extract code to new methods, new classes, and so on. I'll select these 2 lines of code. I'll go to the menu and choose Refactor, and this time I'll choose Refactor This. And this dialog offers all the different refactoring actions that are available. I'm going to choose Extract Method, and I'll name this Print Person. I'll click Refactor, and that extracts the selected code to the new method and adds a call to the new method in the location where that code was originally. Now I'll come back to the person class, and I'll go up to the top of the class, and I'll click into the name of the class. Now I'm going to refactor and rename this class, and I'm going to do it in the definition of the class. This time I'll use the keyboard shortcut, Shift F6, and that's the same keyboard shortcut on both Mac and Windows. And I'll call this person object now. As I type the name of the class, notice that the constructor names are being changed as well. And that's because in Java, the name of the constructor must match the name of the class. I'll press Enter or Return to save the change. Then I'll come back to main.java, and I'll see here that the name of the class has been changed here as well. Now I'm working with a very tiny project with just a couple of classes, but this refactoring works across very large projects just as well. So you can have dozens of references, say to a class, an interface, an enumeration, and you can use refactoring, and all the references will be changed everywhere. In general, it's a good idea to use refactoring to make your changes, rather than simple search and replace functions. Finding and replacing is error-prone. Refactoring is specific because it's looking for the symbols, not just the raw text. IntelliJ IDEA lets you expand abbreviations into full code. These are called live templates. IntelliJ IDEA comes predefined with dozens of live templates for various languages. I'm working in Java, and to use an existing live template, I simply type the abbreviation. I've demonstrated this previously with SOUT, which stands for System Out. When I type that string and then press Tab or Enter or Return, it expands to system.out.println. Here's where these live templates are defined. I'll go to Preferences on Mac or Settings on Windows, and under Editor there's a Live Templates window. Notice that there are live templates for all sorts of languages and platforms. There's Kotlin, Java, Maven, and so on. And for Android developers, there are dozens of live templates under different Android categories. Under the Java section, for example, here's one called for_i, which creates an iteration loop. So I can place the cursor anywhere within a method and type for_i, and then press Tab or Enter or Return, and that expands to an iteration loop that generates a counter variable. Now to fill that in, I can press Enter or Return, and then the cursor will jump to the next placeholder. I can type a value in and press Enter or Return again, and now I'm ready to type the implementation of my for loop. You can create your own live templates by clicking on the Add icon in this window. It's over on the right on Mac, and it might be somewhere else on different operating systems. And notice that you can declare variables within the templates. And this is how you control where the cursor lands as you type in the values in these different placeholders. So index is one variable, limit is another, and end means this is the last placeholder. When you create your own live templates, you must indicate where they're applicable. And you can do that by clicking on the change link here. And for example, this bit of code is a Java statement. So it'll be available whenever your cursor is in a place in the code where a Java statement is acceptable. If you were creating a live template for Kotlin, you would indicate that it was usable in one of these sections, and so on. Live templates let you configure IntelliJ IDEA so that the code snippets you use the most can be inserted into your code quickly and easily with simple abbreviations. There might be times when you need to temporarily store some code in a file that isn't part of the current project. IntelliJ IDEA lets you create scratch files, code files that are associated with a particular language but are stored as part of your user profile rather than as a part of the project. To create a new scratch file, go to the menu and choose File, New, Scratch File. Next, select the language or platform that you want to associate the file with. I'm going to create one that's associated with Java. You get a class named Scratch, and you can pretty much ignore that, and then you can add whatever code you want to this file. I'll go back to my class. Right now it's called PersonObject, but it could be anything. And I'll scroll down here, and I'm just going to make a copy of this toString method. I'll copy it, and I'll paste it, and I'll place it here as a member of this class. Now this method doesn't really make any sense in the context of this class, but that's fine. My goal is simply to store the text. Now I can close all these files, And if I need to find the file again, I can go to the Scratches and Consoles section of the project structure. Just double-click and the file will reopen. You can also find the file by using Search Everywhere. I'll press Shift twice and type Scratch, and there's the file. And there's also a scope in the project window named Scratches and Consoles, and that will filter so it's only showing these kinds of files. And once again, it's easy to open it. Scratch files aren't a part of the project. You can create a Scratch file in one project and then open another project, and it will still be available under the same user profile. To demonstrate this, I'm going to close this project, and I'll open another project that I've opened, and you could create a new one if you're following along. And notice in my Scratches and Consoles scope, that file is still there. Now, I'll delete it from here. I'll select it and press the Delete key, and then click OK to confirm. Then I'll close this project. I'll reopen Hello World, and the file is gone. Then I'll return back to the project scope in my project window. Scratch files are great temporary holding areas for code you want to come back to. And since they aren't connected to a particular project, they offer a great way to transfer code between projects. In this challenge, I'll ask you to build a new Java class named Invoice. The invoice will have a single constructor. Now, if you're new to Java, that just means it's a method that has the same name as the class itself, and this class should have 3 private fields: a title, which is a string, an instance of the Java date class, where the name of the field is date, and a value, which will be a double value. Then, when you call system.out.println and you pass that invoice in, you should see output that looks like this. This will be part of a toString method. Now, as I showed in a previous video, you can generate a lot of that code automatically using IntelliJ IDEA's Generate tools. Start with a brand new project. Then create this invoice class, and I'm not going to show you what it looks like yet. I'll show you that in the solution. And then add this code in the main method to create an instance of the invoice class and output its values. Try this challenge on your own, and then watch the next video to see my solution. In the previous video, I gave you the challenge of creating a class that represented an instance of a data object. The name of the class would be Invoice, and it would have a title, a date, and a value. Now, before I create the class, I want to show you how I've configured this project. I'll go to the menu and select File and Project Structure, and I've set my project SDK at Java 15 and also the project language level at Java 15. Now, I'll go to my com.example package, right-click, and choose New Java Class. And I'll name the class Invoice, and I'll set it as a class. Now I'll declare my private fields. I'll type private and then the data type, and then I'll set the field name as title. Then I'll do the same thing, and this time it's going to be an instance of the Java date class. And this is the date class from java.util. When I select that class, the import is added at the top. And then the last field will be a double value. That's a primitive in Java, so it's all lowercase, and I'll call that total. Now I'll start generating code. I can go to the menu and choose Code and then Generate, or I can press that keyboard shortcut. I'll choose Getter and Setter. I'll choose all 3 fields and then click OK, and that generates my getters and setters. Next, I need a constructor that I can use to pass in the values when I create an instance of this class. I'll place the cursor right here, and once again I'll press Command-N. That's the keyboard shortcut on Mac. And this time I'll choose Constructor, and I'll choose all 3 fields, and now I've generated the constructor. Then I'll move the cursor down to the end of the class. I'll generate again, and this time I'll choose toString. I'll choose all 3 fields, and now I have a good, usable, debuggable toString method. I'll come back to my Java class. In the main method, I'll create a new variable. I'll name it Invoice, and I'll instantiate it from New Invoice. And I'll pass in the 3 values: my invoice, the current date, and in Java that's new, and then the date object. Place the cursor after the word date and press Control Space, and then you can choose date from java.util, and that'll add the import at the top of the class. And then finally the double value, and that'll be a literal of 123.45. To autocomplete the statement, I'll hold down Command on Mac or Control on Windows, plus the Shift key, and press Enter or Return. That moves the cursor to the end of the line and adds the semicolon. Now output the invoice's value. I'll start with SOUT for System Out. I'll press Tab, and I'll pass in Invoice. Then I'll run the code, and there's my output. The goal of this challenge was to use as many different IntelliJ IDEA features as possible so you could reduce the amount of code that you created by typing. That was my solution. How did you do it? IntelliJ IDEA has great tools for analyzing your code and reporting on potential errors and warnings. You can use this regardless of which programming language you're working with. I'm going to demonstrate analyzing my Java project. Now, you don't have to have any code files open, but I'll show what happens if you have at least one file open. I'll start off with my main.java file open. Then I'll go to the menu and choose Analyze, Inspect Code. You can choose an inspection scope, the entire project, the currently open file, or one of these custom scopes, all of your project files, recently viewed files, or a current module, and that's what I'll choose. Then I'll click OK, and after a moment I see the inspection results window appear. You'll see a tree here, and you'll see warnings and errors. Warnings are just notices about something you might be concerned about. So for example, here's a new class file, and I'm told over here that the constructor is never used. And I'm given options for fixing it. I'll double-click to open the file, and then I'll try some of these options. If I click Comment Out, that comments out the entire class. I'll press Command-Z or Control-Z to undo that, and then click OK, and that brings me back to the current code. Here's another potential issue, a for statement that has an empty body. I'll select it, and I see a menu option over here labeled Suppress, and I'll choose Suppress for Statement. Now, a comment is added right above this statement. All of these inspections are based on the lint tool, and there's a whole list of potential errors and warnings for each language that you can configure from within the settings or preferences. When you add one of these no inspection comments above a statement, a class, or at the top of an entire file, you're basically telling IntelliJ IDEA, don't worry about this particular issue the next time I analyze the code. This analysis happens either when you explicitly execute analysis from the menu, or every time you check in code in a source control system, such as Git. Lint comments suppress these errors and warnings. So if you have code that it's identifying as a potential issue, put in the comment, and you won't be reminded again in the future. You can always rerun your analysis anytime, just by navigating that menu again, and then you'll see all the errors and warnings that are left over. These are all warnings about methods that aren't being called from anywhere in your application. And here's that new class file again. And because in this course we're just dealing with small sample applications, you can safely experiment with all of these options for fixing the errors and warnings that the code analysis tool has found. All good integrated development environments have tools to help you debug your code. One of the most important tools for this is the breakpoint. A breakpoint lets you mark a line of code and suspend the application's execution at that point. While you're in a breakpoint, you can then inspect the application's internal state, its variable values, resource usage, and other factors. To demonstrate breakpoints in IntelliJ IDEA, I'll add a bit of code in this for loop. I'll once again use SOUT for System Out. Now output the value is, and then I'll append to that the value of I. Now to set a breakpoint, I'll click in the trough right next to the line number, and this icon means that there's a breakpoint. Now I have to run the application in debug mode. You can do that by clicking on the debug button up here, or you can go to the menu and select Run, Debug Main, or you can right-click on this icon in the trough and choose Debug Main from there. No matter how you launch the application, you'll be running in the same debug mode. Now, when I get to that breakpoint, the application is suspended. While you're in the breakpoint, you can now step through the code using the buttons at the top of this debug window. Step over means execute this line of code and go to the next statement in this scope. Step into means drill down into this method call and debug internally. There's also force step into, step out to move up one scope, and run to cursor. I'm going to use step over a few times, and each time I click, I'm executing the next line of code. At any time, you can also click on the Resume Program button over here, or press the associated keyboard shortcut, and when you're done debugging, you can click the Stop button. Breakpoints can also be conditional. I'll click on that icon, and then in this dialog, I'll set the condition to I equals 5. Notice I'm using the double equals operator, and you're just using whatever syntax is supported in whatever language you're working in, and I'll click Done. Now I'll debug again, and I hit the breakpoint again, but notice that the value of I is 5, and I see that in a few different places. Right here on the looping construct, here on the execution, and also down here in the variables window. And once again, I can continue stepping through the code, and you'll see the display of that variable value change in all those same locations. I'll click Stop to exit the debug session, and then I can look at my breakpoints by clicking on this button. I see all my breakpoints there. Right now I only have one. I can right-click and group them together if I like, or I can remove the breakpoints by clicking on this icon or by pressing the Delete key on my keyboard. Breakpoints are the gateway to all sorts of other debugging tools. Once an application is suspended, you can learn all sorts of useful information about its internal state. When you suspend an application with a breakpoint, you're able to inspect the values of variables, both simple values and complex objects. To demonstrate this, I'm going to get rid of this comment for this statement with empty body lint condition. That's no longer true. And then above the for loop, I'm going to create an array list. I'll start it with a var keyword, and then I'll name the variable people, and I'll instantiate it with new array list. Now for the diamond operator, I'll add in person object. That's my current value object or data object. And then I'll auto-complete the statement with Command-Shift-Return on Mac or Control-Shift-Enter on Windows. Next, within the for loop, instead of just outputting the value of I, I'll add a new object to that people array list. I'll call people.add, and then I'll call new person object. And I'll pass in values that have the current integer I appended. I'll wrap these lines of code to make them a little easier to read. Now I'll add a breakpoint right here at the point where I'm about to add an object to my array list. And I'll run the application in debug mode. Notice in the variables window that my array list named people has a size of 0 and the value of I is 0. Now I'll press the F8 function key, and that adds a new object. And my array list size is now 1, and the value of I is still 0. I'll press F8 again, and I updates to 1. Now here's some different ways that you can inspect variables while you're in the breakpoint. If you simply move the cursor over a variable, you'll see a pop-up that shows the type of the variable, and if it's a complex object, there will be a plus icon, and you can expand it. And here I'm drilling down into the array list and seeing the person objects, and I'm seeing the values of those objects. This shows me that I forgot to put in an extra space next to the word last, and so I can easily correct that. Now, I'll right-click on this breakpoint, and I'll set the condition to I matches a value of 9. I'll click Done, and then I'll resume execution, and when I hit the breakpoint again, the size of the array list is now 9. I'll move the cursor over the people object. I'll see the size again. I'll drill down, and I'll see all the objects in the array list. You can also select an expression, then right-click and choose Evaluate Expression. A dialog will pop up, click Evaluate, and you'll see the same information appear in this dialog. There's also a notation here that there's a keyboard shortcut to add this to Watches. Watches is another window, and it's a way of persistently watching a variable value. I'll press the keyboard shortcut that's notated there, and then close this dialog, and now this variable is there permanently. Notice it's displayed twice, once because it's currently in scope, and once because I said I wanted to add it. But you can add any expression to the watch window. I'll right-click, and then once again I'll choose Evaluate Expression. Within this dialog, I can type any expression. So for example, if I wanted to look at people.size, I can select size with the parentheses because it's a method, and then click Evaluate, and there's the result. Or I can call something more complex. I can call people.get, and then I'll pass in a value of 1, which would mean the second instance of the person object. I'll click Evaluate, and I see just that object. Or I can drill down even further and call specific methods. And now I'm seeing the returned value from that method from that object. Between the Evaluate dialog and the Variables window, you can inspect any value or any expression. IntelliJ IDEA will run all the Java code in the background so you can see what's happening internally in your application. In IntelliJ IDEA, when you build a project, it means you're compiling your Java code into Java class files. This happens automatically whenever you run an application. When you build a project, you'll end up with an out subdirectory under the project. This out directory will have a production subdirectory, and then the name of the project, then a directory structure that reflects your packages. Under there, you'll have class files. If you want to do a complete clean of your project, you can simply delete this out directory, then go to the menu and select Build and Build Project. Depending on the state of your project, you might also see menu items to build just modules, and I'll talk about those in a moment. When I build the entire project, I'll see a notice going by at the bottom of the screen, and then that out directory will be recreated. Now let's talk about modules for a moment. Every project has one or more modules. The modules can be built individually. In my Hello World application, I'm going to select File, New, Module. I'll set the type of module to Java. I'll set OpenJDK15 as my module SDK. Then I'll set the module name as New Module. I'll create the module, and it'll appear right here. I'll go to the source directory, and I'll create a new package that I'll call com.newModule, and then I'll create a Java class within that package. I'll call it New Module Class. Next, I'll once again build the project, and then I'll go to the out directory and show that there's a new subdirectory under production. So each of these modules is tracked individually. When you want to rebuild, you can either rebuild the entire project, or you can rebuild just one module at a time. I'll right-click on New Module and show that there's a menu selection for building just that module, or I can go to the menu, and with that module selected, I'll see that same menu item here. Now, to get rid of the module, I'll go to what's called the Project Structure dialog by going to the menu and selecting File, then Project Structure. I'll select Modules and New Module, and then I'll remove the module from the project and click OK. Then I'll delete that out directory again, and I'll once again rebuild the entire project. And after a moment, that out directory is recreated, and this time it only has the compiled classes for the Hello World module, the module that has the same name as the project. So you can build one module at a time, or you can build the entire project. And again, building in IntelliJ IDEA just means compiling your source code into bitcode class files. Java-based applications make frequent use of external libraries. You can get to these libraries using contemporary repository management tools known as Maven and Gradle, and I'll talk about those in a moment. But there's also an older style of integrating these libraries by going and getting a precompiled and archived jar file and downloading that jar file and integrating it into your project. And I'm going to show you how to follow that process in IntelliJ IDEA. To follow along, you'll need a jar file from some open source library. And I've downloaded this file named JSON 2.8.6. Now, if you want to find that file, you can search for JSON in Google, and then you should get to the link right away. That'll take you to a GitHub repository. From there, scroll down to the bottom until you see the download section. Click on JSON jar downloads. Then at the top right, click on the downloads link, and you'll find the jar file here. To demonstrate this, I've also created a brand new project. This is a fresh project in IntelliJ IDEA that just has a main class. Now I'm going to go to my project window, I'll right-click, and I'll create a new directory. I'll name the directory lib for libraries. That's kind of a traditional name for this sort of directory, but the directory name doesn't really matter. It could be anything. Now I'll come back to my desktop, and I'm going to copy this jar file to my clipboard. I'll go back to IntelliJ IDEA, and I'll paste the library into place. When prompted, I'll click OK. So now the jar file is in the project directory, And to integrate that jar file and make it available to the rest of the application, I'll right-click on it and choose Add as Library. At the dialog, I'll click OK to confirm, and now that library is available to my code. I'll go to my main method, and I'll start typing JSON, and there's the name of a class named JSON. I'll press Control Space and select that class, and that adds a required import for the class. I'll name this JSON lowercase and then say New JSON and add the semicolon at the end. Now I can do anything I want with this class and all of the other classes, interfaces, and other components that are members of that library. When I build and package my application, this jar file will also be integrated. So again, this is a legacy approach. Most modern Java-based applications integrate external libraries using Maven or Gradle. But if you're working with older applications or you just like this approach, this is how you do it in IntelliJ IDEA. In older Java-based applications, to integrate an external library, you would find the jar file for the library, download it, copy it to your project, and integrate it using your IDE, as I showed previously. In contemporary Java-based applications, though, developers usually use Maven or Gradle, two frameworks that handle that download for you and can notify you when there are security issues or other potential upgrades. Now, if you want to use Maven from scratch, you would go to this page and you would copy and paste your dependency. And in fact, you can see there are icons here for doing that. But IntelliJ IDEA handles all that for you. I'm going to create a brand new project, and I'm going to say this time that it's a Maven-based project. It's still going to be Java, but it'll add the Maven framework support. I'll use the same project SDK as I have previously, and on this screen, I'll call this Maven Project, and click Finish. When the project first opens, you'll see a file called pom.xml, and this is an XML file that has a group ID, artifact ID, and version number, and this is for your application. Our goal here is to go get an external library, though, and you don't need to mess around with the source code to do this. You can go back to that project structure dialog. In the project structure dialog, select the modules item, then choose your module, then click on dependencies. Click the plus button. It'll be at the bottom on Mac and maybe over on the right on other operating systems, and choose Library from Maven. Now type the artifact name for the library you're interested in. I'm looking for JSON. I'll click the search button and wait a few moments, and then I'll see a listing of all the artifacts that are available that have JSON in their names. I'll scroll down, and I'm going to find the most recent version of JSON. As of the time of recording, that was 2.8.6, and I'll click OK. Then I'll click OK again, and OK one more time, and I see a message saying the following files were downloaded. Again, it's the same jar file as I showed previously. I'll go to the menu and select Build, and then Build Project. And over here, I'm going to click on the Maven item that's shown up on the sidebar. I'll open this, and I'll see that there's a whole list of what are known as tasks. If you ever see anything stale in these files, you can open this window and click the Reload button, and that will rebuild everything having to do with your dependencies. Now I'll go to my source directory, and I'm going to dig down to my Java directory, and I'll right-click and create a new package. I'll call this com.example. Then from there, I'll right-click again and create a new Java class that I'll name main. Now, to create a main method, I'll use a live template. I'll start typing the word main, then I'll press tab, and that expands to a main method. And within the main method, I'll start typing JSON, and I see that that class is available. And in fact, everything in the JSON library is available now because of that dependency. If you ever need to change anything about the dependency, go back to the project structure dialog. Once again, choose Modules, choose your module, choose the Dependencies tab, and then you'll find the dependency. You can double-click on it, and you can then make changes. Or you can right-click and choose Edit, and it'll take you to the same place. So again, there's a lot of source code and configuration files that are doing this work in the background, but IntelliJ IDEA makes it automatic. Get used to using that project structure dialog to set up your dependencies and manage them for your Java-based application. When you're finished with a Java-based application in IntelliJ IDEA and you're ready to distribute it, you're going to package it in a jar file. That's a zip-style archive file, and IntelliJ IDEA will give you all the tools you need to define and generate the file. I'm working in a brand new project with just a main method, and I'll just add a little bit of code. I'll call system out and pass in hello from the jar file. Now I'll run the application just to make sure everything works as expected, and I see that output. In order to define the jar file, go to your project structure dialog. From there, click on Artifacts, and then click the plus button, choose Jar, and then from Modules with Dependencies. Select the module that you want to put into the jar file, then browse and select the class you want to execute as the jar file starts up. You can accept all the other default settings and click OK. Then click OK again, and your artifact is ready to build. Now go to the menu, and this menu item should now be active. Select Build Artifacts, and then on the menu that shows up, choose Build. You'll see a status message briefly at the bottom of the screen, and then go to your Out directory in the project, and you should see a new Artifacts directory. And there you should find your finished jar file. Now to test this jar file, I'm going to right-click on it, and then I'll select Open in Terminal. Now the next step is only going to work on Windows if you've added the Java directory to your system path. On Mac, that's automatic. But if you've done that on Windows, you should see the same result as what I'm about to show. Notice that I can list the contents of this directory, ls on Mac and Linux or dir on Windows, and I see that the jar file is in the current directory. Now I'll type java-jar. That means I want to run the contents of a jar file. Then I'll type the first letter of the file name and press Tab, and it'll auto-complete. And then when you press Enter or Return, you should see the output from the application. Now this is a very simple sample application, and it's just doing one little thing, but the point here is that creating the jar file is a simple process, no matter how simple or complex your application is. And again, it's two steps. First, define the jar file as an artifact, and then build that artifact. And then you can take that jar file and send it to all your users, and they'll be able to run it using their installed copy of the Java virtual machine. JavaDoc is a tool that's included with the Java Development Kit. You can use JavaDoc to generate documentation for your application based on comments that you put in your classes, interfaces, and other source code. First, you'll need to add JavaDoc comments. A JavaDoc comment starts with a slash and two asterisks, and in IntelliJ IDEA, you can type that string and then press Enter or Return, and it'll expand. The JavaDoc comment ends with an asterisk and a slash, and every line in between should have an asterisk at the beginning. You can place a JavaDoc comment before any symbols. So for example, you can put it before a class name, and I'll say this is my startup class. And then you can also add one before the main method. Once again, I'll type slash asterisk asterisk and press Enter or Return. And I'll say this is the startup method. And then for your parameters that are auto-generated, you can add comments there too. This is the collection of strings passed from the command line. So now I have two different JavaDoc comments. To use those comments to generate my documentation, I'll go to the menu and choose Tools, Generate JavaDoc. In this dialog, you can choose the scope of the Java documentation that you're generating, and I'll leave it selected to whole project. You can also link to external documentation and also filter based on a lot of other settings. One very important thing you should do is set the output directory. Make sure you're choosing a directory that's specifically for this content. If I were to generate the documentation right now, having chosen my desktop directory, I would create all kinds of files and folders right there on the desktop. That's not what I want. So I'm going to create a new folder that I'll call My Docs, and I'll put that inside the desktop directory, and click Open, and then click OK. This is a very small application, so it takes just a moment to build. I'll get rid of all these other tabs, and show this documentation starts off with my main class, and there's my JavaDoc comment. This is my startup class. I'll click into the class, and I'll see that there's an auto-generated no-arguments constructor named main, the same name as the class. And here's my main method with the comment, this is the startup method. And that comment will show up there, and it'll show up anywhere else where that method is documented. Here's the args parameters, and once again, there's my comment. This is the collection of strings, and so on. Now, this is not an in-depth tutorial on how to use JavaDoc. There are other tutorials that will take you more deeply into this tool. The important thing here is that once you've added all your comments to your Java source code, you can use the JavaDoc tool from within IntelliJ IDEA by simply selecting it through the menu. IntelliJ IDEA includes integration with Git, one of the most popular source control products out there. Before you can use Git with IntelliJ IDEA, you have to have the software installed. You can find out whether you have Git installed by going to a command window. On Mac, I'm in Terminal, or on Windows, you might be in PowerShell, and then type git -- version. If the product is installed, you should see a version number. Now, if you don't see anything, you can download Git for free from this website, git-scm.com. You'll find information about Git, and right down here you should see a link to the latest version of the product for your operating system. The installation of Git is pretty straightforward regardless of which operating system you're using. You can just accept all the default settings, and then once Git is installed, you can run that test again and make sure that you can get to Git from the command line. If you can see the Git version from the command line, you're ready to use Git from within IntelliJ IDEA. Once you have Git installed, you can create what are known as repositories. A repository is where you store your source code files, and Git tracks all of your changes. Each time you make a change, you commit those changes, and then you'll have multiple versions of the application. Now, while it's very common to start off with Git by creating a repository online, you can actually create Git repositories that are purely local. To demonstrate this, I'll create a new Java project. I'll create the project from the command line app template, and I'll name it Git Project. Once the project has been created, I'll add a bit of code to output something to the console, and I'll say hello from Git. Then I'll run the application just to make sure all that simple code works. And there's the output. Now to create the repository, I'll go to the menu and select VCS, Import into Version Control, Create Git Repository. Now you're asked where you want to put the repository, and the most common location is right there in the project directory. So I'll click Open to select that, and there will be a couple of subtle changes to the user interface. Down here in the lower left corner, there will be a new Git tab, and when you click it, you'll get into the Git window. And over in the lower right corner, you'll see a list of branches. When you create a new repository in Git, you'll see a first branch created. Traditionally, this has been called master. In more recent versions of Git, it's now called main. But either way, this is your starting branch. Now, you won't see any directories here in the project because they're hidden. But I'm going to right-click on my project, and then I'll select Open in Terminal. And I've landed in the directory where the project is stored. On Mac, I'll type ls dot, and once again, I'm only seeing the IML configuration file and the out and source directories. Now I'll type ls.git, and I see that that directory actually exists, and there's a bunch of subdirectories. That's your Git repository, or repo. You won't want to change anything about those directories. They're all managed by the software. But now that the repository has been created, I can check in my code. I'll go to my Git project, to my source directory, and I'll choose my one and only Java file, right-click, go to the Git menu, and choose Add. Next, I'll go to the Git tab. Everything still looks pretty much the same, except I now see another command. I'll click the ... to expand it, and you'll see that the command to add files to Git is actually fairly extensive. Next, I'll go to the project window and right-click on the file again, to Git, and this time I'll choose Commit File. In this interface, I'm being asked to add a comment. Every time you commit something, you must provide a comment, and I'll just say this is the initial commit. Then I'll click the Commit button, and my change has been saved. So that's the beginning of how you can create a local Git repository. Again, you don't have to use an online repository, say at GitHub. You can do everything locally. But the advantage of working online is that you're saving your code to somewhere different. So if something happens to your local development computer, you can recover easily. So for the rest of this chapter, that's where I'm going to focus. Uploading your code to GitHub so you can commit your changes there And then, if something happens, you can roll it back and get back to an earlier version. GitHub is one of the most popular websites for managing Git repositories. You can create a GitHub account for free, and you can store your projects there for free as well, up to certain limitations. In order to upload your projects into GitHub, you must have a GitHub account. So start at this website and sign up if you haven't done it already. When you sign up, you'll be asked to provide a username, an email address, and a password. And you might be prompted with other security features. You'll then be asked to determine whether you want to authenticate with just a username and password, or whether you want to use two-factor authentication. That's entirely up to you. But then, once you've set up that account, you can come back to IntelliJ IDEA and configure IntelliJ IDEA to work with your account. From the Welcome screen, select Configure, then go to either Settings or Preferences, go to the Version Control section, choose GitHub, and then add your account. When you're working from within IntelliJ IDEA, you might be taken to this website. I'll click Authorize in GitHub, and then I've typed in my information, and I'll sign in, and then I'm asked for an authentication code. I'm using two-factor authentication. In my case, I'm using Microsoft Authenticator, and so while you can't see this, I'm looking at my cell phone, and I'm opening the Authenticator application, and I'm typing in the password code that's displayed there. And now I'll click Verify, and then on this screen I'll select Authorize JetBrains. Once you see this message, you can close the browser and then return back to GitHub, and you'll see that you've been authenticated. You're now ready to use GitHub from within IntelliJ IDEA. Once you've configured GitHub in your IntelliJ IDEA installation, you can create a repository directly from within IDEA and upload it to GitHub. I'm starting with a fresh project that I've named GitHub Project, and if you're following along, you can start with any new project. I've also configured GitHub in my software, and now I can go to the menu and choose VCS, Import into Version Control, Share Project on GitHub. First, you'll see a dialog indicating that you're being authenticated, and once that goes by, you'll come to this Share Project on GitHub dialog. Now, I'm going to expand this so I can see the whole thing. There are just a couple of options here. First of all, each GitHub project can either be public or private. If it's public, other users on GitHub can see it and search for it. If you want to keep it private, just check the option. All GitHub memberships support private projects. If you like, you can add a description. I'll just type in a string of my GitHub project, and then click Share. When you do this, everything in your project will be added to the GitHub repository automatically, and then you'll be asked to commit your files. Notice that you'll be checking in both your source code files and a number of configuration files from the .idea directory. There's also the .iml file that configures the project itself. Now, not all files are being selected, and I'll show you why in a moment, but for now, I'm just going to click Add. Down at the bottom of the screen, I see the message that everything is being checked in, and then an indication that I successfully shared the project on GitHub. I can click this link, and I'll be taken directly to the project on the website. If I made it a private project, I must have already logged into GitHub on the website in order to see it. The URL will start with github.com, and then you'll see your identity and then the name of the repository. One very important thing is that GitHub repository names can't have spaces in them. So when you create the repository, just make sure it's a simple string, no spaces. Now I'll come back here to IntelliJ IDEA and click on the Git tab, and I'll see in the console a listing of the output of the checking in operation, and then in the log console, I'll see all the operations that have been executed so far. I can click on one of the operations and see a list of files over here. I'm going to click and drag this up so we can see this more cleanly. And I'll see the commit comment, initial commit. So that's how you can create your own GitHub repositories from within IntelliJ IDEA. GitHub repositories are online, and so they can be used by multiple developers. Each day, when you start working with a particular repository, you might want to pull down changes that have been made by other developers. I'll demonstrate how to do this by adding a new file from the GitHub project's website. I'll click Add a README. That will create a new README file in the Markdown language. I'll scroll down a bit. I'm just going to accept the default text, And I'll go all the way down here and click on Commit New File. So now the file exists in the online repository, but it doesn't exist yet on my local copy. From here, I'll now go to the menu and choose VCS, Git, Pull. I'm asked where I want to place the new files, which branch. Now, the name of your primary branch will depend on when you created it. In current versions of Git, the initial branch is called master, but by the time you watch this course, it might have changed to main. But either way, just accept the default here and click on Pull. Wait a moment, and then you should see the readme.md file appear. IntelliJ IDEA has support for the Markdown language built in, so you'll see the code for the file on the left and the preview of the file on the right. If you created the README file on the GitHub website and you've successfully pulled it down, then you know how to update your local repository with changes made in the online version. When you make changes to your application and want to check them into version control, that's called committing your changes in Git. To demonstrate this, I'm starting with this fresh project that just has a main class, and I'm going to add a new Java class that I'll call person. Each time you add a new file to a project that has a Git repository, you should see this dialog asking whether you want to add the following file or files to Git. I'll click on Add, and now I have uncommitted changes. I'll come back to the main class, and I'll add a reference to that new class. I'll create a new variable called person, and I'll instantiate it with the person class. And now I have changes in 2 files. Now I want to commit those changes. I'll go to the project in the project window and right-click. Then I'll choose Git and Commit Directory. I'll see this user interface pop up. I see a listing of all the files that have changes. I can click on any of these files and see the changes by pressing Command-D on Mac or Control-D on Windows. And I'll get the diff window. This shows me the differences between 2 versions of the file. Now, if I do that on a file that's changed, I'll see 2 sides to the window. But if I click on a new file and then press the same keyboard shortcut, I'll just see that file. You might also see files that you don't expect, such as configuration files. If you see those, it's usually a good idea to check them in as well. Next, I'll set a commit message, and I'll say, these are my changes. Down here, click on the down arrow and choose Commit and Push. Commit means save your changes to the local repository, and push means upload them to the remote repository. I'll click on Push, and at this point, if there are any issues with your code, you might get a dialog that pops up and notifies you. It'll give you a chance to back out the commit and make any fixes before you commit your changes. Now, there's another user interface that's available here. If you prefer, you can go to the Options menu and say Switch to Commit dialog. Now I'll make another change, and I'll call System out and pass in person. And this time I'll click on the Git tab down here, and I'll see a very different user interface. This is an older UI for Git, and in this UI there are buttons on the left. You can click on the checkbox to commit the entire set of files. Once again, you can select a file and press Command or Control-D to see the differences between the files. I'll select what's known as the default change list, click the Commit button. I'll change the commit message to these are my second changes. And then down here, I'll pull down the arrow and choose Commit and Push again. Now, once your push operation is complete, you can go back to the GitHub website and refresh. And you might see messages indicating that changes have happened here. And you can click into your packages, and you should see the changes in your source code files. So uploading your changes consists of a few different steps. For new files, you have to add them to the repository. For changes, you have to commit them. And to upload those changes, you have to push. If you want to return to the newer Git user interface, go to Settings or Preferences, then go to the Git section under Version Control, uncheck the option for Show Push dialog for commit and push, and you should be back to the newer UI. When you use Git to manage your software, you can create new branches, whole new sets of code, and then you can switch between the branches. The most common pattern is to create a new branch when you're starting a new version or a new feature, make your changes and test them in the new branch, and then when you're finished, merge those changes back to your primary branch, master or main. To create a brand new branch, go to the menu and choose VCS, Git, Branches. You'll see a list of your existing branches, and you can click on New Branch. Next, enter your branch name. Branch names are typically all lowercase, no spaces. So I'll just call this My Changes, and click Create. Now I can make changes to my code. I'll go to my project window and open the person class, and then I'm going to add a couple of fields. I'll start with private string first name, private string last name, and private int age. Next, I'll generate my setters and getters by going to Code, Generate. I'll choose Getter and Setter. I'll choose all of my fields and click OK. Now I'm going to commit my changes. I'll go down here to the Git tab and click on the checkbox to commit my changes, and I'll set the commit message to This is my new branch. Then I'll click on Commit and push, and now I have two branches, my primary and my secondary branch. I can now switch between the branches from a couple of different places. I could once again go to the VCS menu and choose Git, Branches, and that'll open up a dialog. Or I can go down here to the lower right corner and click that icon, and I'll see the same dialog pop up from the lower right. I'll choose Master and check out, and I see that my person class has reverted back to its original setting. Then I'll go back to the branch list, and I'll choose My Changes and check that out, and all those changes come back again. Now, when I want to take those changes and merge them back to my primary branch, I can go back to the primary branch, and again it's called Master in this project. I'll check it out, then I'll go to my branch list, I'll choose My Changes, and I'll choose Merge into Current. You'll see this dialog pop up whenever you execute that operation, and over here you might see a prompt to delete the branch that had the temporary changes. If you're done with that branch, you can just click that link and it'll go away. Now, my local repository has those new changes, but I haven't uploaded them to my remote repository. To do that, I'll go to the menu and choose VCS, Git, Push. I'll see this dialog pop up showing these are the changes that you've made, and I'll click the Push button, and my changes are uploaded to the remote repository. I'll go back to the remote repository, I'll refresh, I'll click into my base package, and then I'll click into the person.java file, and I'll see all the changes are reflected there. You can create as many branches as you like. Now, to make the most of Git, you need to understand a lot about the software itself, and there are courses available to learn about Git and GitHub in more depth. The important thing to know about IntelliJ IDEA, though, is that most of Git's common operations are supported from within the Git user interface. There are lots of Git features that aren't directly supported by the IDEA interface, and for those, you can always go to the terminal window and type in your Git commands. Git has another really useful feature that lets you take a bit of code and save it into a file that's not a part of a larger project. This is called a gist or gist. You can pronounce it either way. And creating a gist from within IntelliJ IDEA is really simple. First of all, you have to have configured IntelliJ IDEA with your GitHub account. But then you can go to any file in the project window, right-click on it, and select Create Gist. If you like, you can create a description, and I'll call this My Person class. You can select any of these options, including Copy URL, and then click OK. If you select the option Open in Browser, after the gist has been created, you'll immediately go there. And if you selected the option to copy the URL, you'll be able to navigate to the gist that way as well. Once you've created your gist, it will be attached to your GitHub account, and anyone who has the URL will be able to see it, even if you labeled it as secret. So this is a great way of sharing code with other developers. And once you've created the gist from IntelliJ IDEA, you can make changes or delete it from the GitHub website. IntelliJ IDEA supports many languages other than Java, and it's particularly strong when using languages that run on top of the Java Virtual Machine, or JVM. Groovy is one of these languages. It's an open-source language that's managed by Apache, and you can download the Groovy SDK from this webpage at groovy-lang.org. I've already downloaded the zip file for the most recent version of Groovy as of this recording to my desktop, and I'll extract the contents of the zip file right here. After extracting the contents, you'll have a folder that has the same name, and you can actually move this folder anywhere you want on your computer. I do recommend putting it in a directory where the entire path doesn't have any space characters. I'll leave it on the desktop for this demonstration. Now I'll create a new project, and I'll choose Groovy as the language. I need a Groovy library, and that's the directory that I just downloaded. I'll click Create. I'll navigate to that Groovy 306 library and click Open. And now my Groovy library is created. It's called a global library, meaning it can be used for many projects. I also need an SDK other than Java 15. Specifically, I need Java 8, and that's because Groovy was built on top of the Java 8 SDK and works best there. I'll go to my Project SDK pull-down and I'll select Download JDK. Then for the vendor, I'm going to choose Adopt OpenJDK OpenJ9. For the version, I'll choose 1.8, and that's Java 8, and I'll download. It'll take a few moments to download the JDK, and then I'll be ready to continue building my project. I'll click Next, and then I'll set my project name to Groovy Project, and it'll go in the Groovy Project directory under IDEA Projects, and I'll click Finish. When you first open the project, it might take a few minutes while the Groovy JDK and the Java 8 SDK are both scanned and indexed by IntelliJ IDEA. But while that's happening, you can create your first source code file. I'll go to the project window and go to the source directory. I'll right-click and choose New, and then I'll select Groovy Script. Don't choose Groovy Class at the top. That works differently. I'll set the name to Hello, and I'll choose Groovy Script. And then, in this file, I'll type print ln, and then hello from Groovy. Unlike Java, you don't need a semicolon at the end of the line, and print line is a command, not a method or function, so you don't need parentheses. Now to run the file, I'll go to the project window and I'll right-click on hello.groovy, that's the name of the file, and I'll select Run Hello. After a moment, the project is built, and I see the output in the console, Hello from Groovy. So those are the steps to getting started working with Groovy in IntelliJ IDEA. You need the Groovy SDK from Apache, the Java Development Kit, specifically version 8, and then you can set up your Groovy project and start coding.